Hello, so today we're going to be working on problem number 2 for assignment 10. Before we start making the problem, I would like to point out that the diameter given in the part in the file is incorrect. It's not 0.635. The correct diameter for this cross section is 0.025, so that's given. With this information, we need to find some other important values before we get started on making this part that are going to make the process a little bit easier on us. Um, so one of those values is this gap here. So that should be 0.0025 inches, and I'll show you how to get that right now. So to find this gap, we would take our overall width. So I'll do this in a different color. So we would take our overall width, 0.265, and you would subtract this distance, just put you from here to here. So minus 0.21. Now we need to subtract another radius of that cross section, and then we have two radiuses on each side. So two there, one here, and then so four radiuses total, which is the same as two diameters. Let's subtract 2, and then we have our new diameter, 2, 5. And then the last thing to set up our equation would be to add the gaps into that. So we have two gaps, which I will call 2x, and we'll set this equal to 0. And if you solve for x, that would give you your value for your gap here, which we know now is 0.0025. Once you have that value for your gap, we should use it to find this diameter for this arc. Excuse me. To find that diameter, we would take our initial value of 0.21, which we know is this distance, and you would add one radius, two radiuses, so you would add a diameter. I'm sorry, that's the gap. The diameter would be 0.025, I believe. Just having an issue here with my laptop's being a little slow, so just bear with me. So oops, didn't mean to make that line. Our radius is 0.025, correct. And then also we need to add a gap. So we add 0.0025. That would give us our um, diameter for this bottom arc. So that's the math that we need to do. Let me erase this to clean it up a little bit. And I will also erase the math now that it was shown. We're left with our important values. Let's get rid of that. All right, so now we can start a new part file. Let's also make sure that our units are in inches. So let's switch that over. So the sketch that we'll be making right now is going to be the path for our sweep that we're going to use later. So we're going to make this we're going to make this front view. Um, so let's make a sketch on our front plane. And my origin for me, I'll use this point. So I'll start by making a vertical line. Now the distance for this vertical line will be this 0.57 minus a radius of this arc. So I can do 0.57 minus a radius of this arc. I know its diameter is 0.21, so I can do 0.21 divided by 2. That would be the distance for that first line. And I will have an arc that's center is in line with this endpoint. And this arc will measure 0.21 in its diameter, so its radius is half of that. And if I also dimension the center point of the arc to this endpoint and make that the same distance as my radius, and then it looks like it changed the size of that arc. So let's redimension this to be the same, 21.21 over 2. It also changed the distance of this line. Let's go back and redo the math again. 0.57 minus a radius, so 0.21 over 2. Use some parentheses there to keep it nice and neat. Now, if we start a line from this quadrant and go down, we need to find the distance from, let me get rid of this. Okay, we need to find the distance from this quadrant to this quadrant. By doing that, or to do that, we will take this 1.04 and subtract a radius from this arc. So let's use parentheses here to keep it nice and neat. And then we'll also subtract the radius from this arc, which it's good that we found its diameter earlier. 0.2375 divided by 2. I believe it looks like my 7 was erased there on accident. Let me just add that back in. So there's my 7. So that gives me the distance for this line. Again, let me make a circle in line with this endpoint. And also let me fix what I already have made, just in case. It looks like I can't. Maybe one at a time. Let's fix these in place. Let's add the dimension first this time. So this should be the radius of this bottom arc. So we'll do 0.2375 over 2. Let's also change this to the same value. Okay, let me also fix this just in case. And let me start from this quadrant. So this left quadrant and go upwards. To find the distance for this line, the math will be the overall, so 1.3 minus a radius here for this bottom arc and also a radius for the top arc. So for the bottom arc, we have 0.2375 over 2, and then for the top arc, 0.265 over 2. So that's that distance. Let's also make the arc, that's the top arc. And what's good to know about this arc is that it is in line with the one below it. So if we know its center is in line with this endpoint and also the arc below it, and then we dimension it here to the endpoint, this would give us our radius. So our radius is correct because if you multiply this by 2, you'd get 0.265. And then our final line will be from this right quadrant down to where we started. So in line with the origin. And to get our final path, let's trim the arcs that we don't need. So this bottom arc, don't need this one either. And we don't need this one. So there's some conflicts here. Let's just finish our trim. I don't believe it likes some of these constraints. So we delete some of the fixing constraints. Hopefully that'll clear that up, which it did. Again, so this is our path for our sweep. So now if we go over to sweep, since we have a circular cross section, we can select circular profile, and that will only ask us, now it only asks for our path. Our path is already highlighted. And for the sweep, it does ask us for the diameter. I know most of the time when we're working with arcs, it's SolidWorks asks us for a radius, but in this situation, we're looking for a diameter. So let's type that in, 0.25, and everything looks fine. So now if I move on over to my isometric sketch, you should see that that's the problem number 2 completed. So that's it.